All right, in this video, I am going to show you how to solve linear equations. Now, there are basically two tools that you have to solve linear equations. You can either add and subtract the same thing to both sides. That's called the addition property. I notice your worksheet calls them the addition and subtraction properties separately. That's fine. Or you can multiply or divide the same thing on both sides. Okay, so here we've got two equations. These are the first two equations on your sheet. We are going to solve both of these. So my first step on this equation, I'm asked to solve for x, is actually not a solving step. It's going to make this look prettier. I'm going to get rid of the parentheses by distributing. So this is the distributive property. I'm going to take the 2 times the 3x, and 2 times 3x is 6x. And then I'm going to take the 2 times the 0.5, and you all got calculators, so this shouldn't be too big of a deal. 2 times 0.5 is going to be 1. And then on the other side, this is not in parentheses, it's on the other side of the equal sign, it's equal to 25. Now I have my equation, I'm ready to solve. My general format for any equation is I want to get all of my variables on one side, all of my numbers on the other side. On this equation, the only term that has a variable is this one, so it's already on its own side. So that means the thing that I need to move is the 1. I need to move the 1 because I always keep the equal sign in the middle. And so this is 6x plus 1 equals 25. So the opposite of adding 1 is going to be to subtract 1. So I'm going to subtract 1 from both sides of the equation. And so what happens here is I have 6x. 1 minus 1 is 0, so that means these two things cancel. And then I have 25 minus 1 is 24. Last step, this is always going to be your last step. I'm going to divide by the number in front of the x. And you might say, why am I dividing? Because this says 6 times x. The reverse operation of multiplying by 6 is to divide by 6. So I will divide both sides by 6. And that gives me, on this side, 6 divided by 6, that becomes 1. We say that those two things cancel. And 24 divided by 6 is 4. Now, this is extra, but what this is called is a conditional equation. It means that this equation here is true under the condition that x is equal to 4. So we're going to do the same thing for this one. I would encourage you to go ahead and pause the video and give this a try and then compare what you do with what I do. We'll notice on this second equation that I have variables on both sides. I've got 2k right here, and I've got a k in the parentheses. So it is a little bit more, there's one extra step that I have to do here. So here goes. On the left, I'm going to leave that 4 minus 2k. On the right, I'm going to beautify this. Negative 5 times k is negative 5k, and negative 5 times 7 is negative 35. So I've got k is on both sides, I've got numbers on both sides. So your strategy is always to do the following. You want to get your variables on their own side, you want to get the numbers on their own side, you want to keep this equal sign in the middle. And sometimes in some classes I've had students that just draw a little dotted line here to remind them. If you want to do that, that is great, but I just don't want everything to look too messy. So what I'm going to do is I'm going to bring this 5k over to the left. Mr. Perkins, could I put the 2k over on the right? You certainly could, okay? I'm gonna put my variable on the left in this problem. It's not right, it's not wrong, it's just what I'm gonna do. So I'm gonna add the 5k, and the reason I'm adding the 5k is this is a negative. The opposite of a negative number is positive. And so I have 4, negative 2k plus 5k is plus 3k. And then the 5k's cancel over here, and I have negative 35. Be very careful of your signs. Don't be lazy with those. Now I'm going to bring the 4 over to the other side because notice I've got all of my k's on the left. I need to have all of my numbers on the right of the equal sign. So I'm going to subtract 4 from both sides. 4 minus 4 is 0, and I'm left with 3k. And then negative 35 and negative 4 is negative 39. And again, your last step is always going to be to divide by what's in front of the k, or the x, or whatever the letter is. And so I get k is equal to negative 39 divided by 3 is negative 13. So those are our first two examples of solving a linear equation. Here's the third example. Notice both of these problems have been what's called a conditional equation. They are both true under one specific condition. In this case, x was 4. In this case, k was negative 13. So here's my next example. In this example, we are going to solve this one for y. So here's the problem. We're going to solve this for y, and it says we have 3 over 4 times 4y plus 8 is equal to 5 plus 3y. So these problems have all had kind of a common way to start. We're applying the distributive property. So on the left here, I've got 3/4 times 4y. Now, don't be afraid to use your scratch paper. I'm going to come over here. Hope you can see. I've got 3/4 times 4, which is 4 over 1. And that becomes 3 times 4 is 12. 4 times 1 is 4. And 12 over 4 is 3. So I get 3y. And then 3 over 4 times 8, I'm distributing. So again, my scrap work. I've got 3 over 4 times 8 over 1. 3 times 8 is 24. 4 times 1 is 4. And 24 over 4 is 6. This problem now is just like the previous one we did with the k's. I've got y's on both sides, I've got numbers on both sides. So what I'm going to do is I'm going to get all of my variables on one side and all my numbers on the other. So I'm going to bring my 3y, I'm going to bring it all over to the left. Remember, your equal sign stays in the middle. Draw a line if you need to. So I'm going to subtract 3y from both sides. And something unique happens on this problem. Notice 3y minus 3y, the y's cancel on the left. And 3y minus 3y, the y's cancel on the right. So I'm left with this equation that has no more y's in it. I don't need to worry about bringing numbers over to the other side. What I've got here is 6 equals 5. Ask yourself, is that true? If somebody gave you $6 and you gave them $5, are you equal? The answer is no. What this is called a contradiction. And what that tells you is that there was no value of y at the beginning that would make both sides equal. Okay, so there is no solution to this problem. There is no value that I can plug in that's going to make both sides equal. And so we're going to leave the answer like that. There is no answer to that problem. I've got one more example that I'm going to do for you. And so we're going to come over here. We're going to erase this problem. And this last problem looks like this. Let's say I have 10c minus 6 times 2c minus 1 is equal to negative 2c minus 3. And we are asked to solve this one for c. All right. Well, again, I have the same first step that I've had in every other problem. Got to get rid of those parentheses. So here goes. Negative 6 times 2c is negative 12c. Negative 6 times negative 1 is plus 6. Negative 2 times c is negative 2c. And negative 2 times negative 3 is plus 6. I'm going to do one more thing before I solve. Again, I'm just trying to make this look pretty. I'm going to collect my like terms. I have like terms on this side. And in case you're unfamiliar with that, like terms means that I have the exact same variable part for both of those problems. So here goes. 10 minus 12 is going to be negative 2c. My process is always the same. I'm going to get all of my variables on one side, so I'm going to put all the c's on the left. So I'm going to add 2c to both sides. So notice, very similar to the previous problem, I get another unique situation. Negative 2c plus 2c is 0. Those both cancel. I have 6. Negative 2c plus 2c is 0. I have 6. This time, though, I get a little bit of a different conclusion. 6 equals 6. Is that a true statement? Indeed it is. 6 is equal to itself. What this is called is an identity. And what that means is that it doesn't matter. You can plug in any value for c and you're going to get a true statement. And so when you have an identity, there are infinitely many solutions. In fact, another way to say infinitely many solutions is you would say all real numbers. Any number that you can think of would be a solution to that equation. And that's how you solve linear equations.